It's my great pleasure today to introduce Daniel Whiteson. Daniel is a very many-faceted person. If you approach him from one angle, he looks kind of like me. He's a particle physicist who works in very large experiments in Europe, me on CMS, he on Atlas, working with giant detectors with lots of people. But if you approach him from another angle, he looks a little like Kaustub, working on particle phenomenology. If you approach him from another angle, he looks a little like Paulo Badacchi, working on neutron stars. However, today, we're going to learn about a very different thing. When I organized the DPF 24 conference, I learned that he's a gifted artist and a very gifted science communicator. And I enjoy his talk so much, I thought, oh, we have to have him come here to Maryland and give this talk. So today we are going to learn about science outreach, science communication, and something we're all very good at, science miscommunication. So where do we put this?
All right, well, thank you very much for that wonderful introduction. It's a pleasure to see everybody here who I already know. Of course, I know the particle community here very well, world famous folks in lighter physics and in theory, but it's a pleasure to meet everybody else here. And of course, it's wonderful to escape the terrors of winter in Southern California. So thank you for the excuse to come out here. And I'm deeply impressed by this incredible technology. So I'm a little worried to step onto this and then be disappeared. Bear with me. All right, it'll be those. Just moving up. All good.
On the theme of communication, you're checking the volume, Keon.
The microphone. This is your microphone, no?
That's after the microphone.
Oh yeah,
It's on.
How's that? Did everybody hear me? Good. Fine. Okay. All right. Looks like we're good to go. Okay. So as you were told, I'm Daniel Whiteson, and today I'm going to be talking to you about my experiences in science communication, my personal journey. I'll tell you why I think we should be doing science communication. Talk a little bit about some successes, some failures. Then I'm going to end with a case study about maybe the widest failure in science communication, at least in my opinion. Okay, so number one, why should we do science communication? Because our science is awesome. Okay, the kind of things we're doing, we lose sight of this sometimes when we're buried in it day to day. You're solving some problem, you're getting your code to run, but the kind of questions we're answering with our science are questions everybody has. How did the universe begin? What is the whole universe made out of? These are things with very broad appeal. Lots of folks out there who are not scientists or not even that into science, they have thoughts about these questions. They have questions about these topics, and they want to know the answers. So there's a huge audience out there, and the kind of stuff we're doing is really incredible. It's totally worth sharing. So like, number one, our science is worth communicating. Number two, we don't own it. Science mostly funded, until recently, by the government, right? Which means that it's a public good. The reason we do science in universities is because the good is so widespread that a lot of times big corporations aren't interested in making these investments because they don't know their $1 billion is going to turn into some product necessarily. But we know that investment in science is a public good. It generates education and technologies, and if you're into that kind of thing, military toys or whatever. But it's paid for by the public, which means everybody owns it. Everybody owns it, right? So it's by the people and for the people, which means, for example, professors at large public universities, I think, have some obligation to make it accessible, to break down the walls between us and the wider public who are paying for this and for good reason. Now, near to your heart.
We have forgotten because we keep hearing that 2014 has been the warmest year on record. I asked the chair, you know what this is? It's a snowball, and that's just from outside here.
This guy thinks that because there's still snow, therefore global warming is a hoax, right? So clearly, there are folks out there who are making important decisions that affect my life, your life, our children, the future of humanity even, that need to understand science better. So there is a public out there that needs to be educated. So I'll tell you today about my experience in science communication. I've written some books for a popular audience. podcasts, again, for a popular audience, television show on PBS. I also want to talk briefly about why you might not want to do science communication and what it's like as somebody who is trying to do research, mainstream science research, and doing a sideline in science communication. And the biggest challenge I've had is that most people think that if you're doing public-facing things, if they get to know you via a public audience rather than a professional scientific audience, that you're no longer really doing science. And so the question I'm most often asked by well-meaning colleagues when they see me is this one. Oh, hey, I saw your book, that's cool. Are you still doing research? Right? The implication being you can't possibly do science communication and public outreach and all that stuff, and also be taken seriously as a scientist. So it's been a challenge. Let's talk briefly about how science is communicated and how it should be communicated. So traditionally, technique is something like this, or the industry is something like this. You're a scientist, you do your science, right? And if maybe something exciting happens, you write a paper, and potentially your university gets excited about it, they put out a press release which you hope reflects some actual science that was done in your lab. Maybe your reporter convinces the editor that it's interesting to write an article about it. Maybe that article is actually related to the science that was done. Then it goes out into the media, the internet, your grandma hears about it. Hopefully some of the words at least are related to what actually happened in the lab. And the end result is often something like this. An article. If somebody in the public reads it, they're like, wow, cool, scientists can teleport stuff into space, man. And there is really cool science at the heart of it. It's just not what the reader thinks it is. And closer to home, I read public science communication in my own field. Like this is an article about the discovery of the Higgs boson, in which I was involved, right? And it has the sentence in it that we have revealed the deepest layer of reality our species has ever probed. And I don't know if I'm just not smoking enough banana peel. I don't really know what that means. And this is my field, right? More broadly, it's not hard to find examples of science communication gone wrong. Here's in the New York Times. There's a study about the correlation between the number of books you have in your house and the reading achievements of your children. Correlation between the two things, right? And they sail right through the obvious statistics, and they say the implications are clear. Owning books in the home is one of the best things you can do for your children academically. So just go out and buy books by the yard, right? Clearly, correlation works however you like. And if correlation and causation are the same thing, then you'll need a lot to answer to. Because Internet Explorer is clearly the cause of all the murders in the United States. And so, as usual, we have to go to the cartoonists, the jokesters, to give us the clearest understanding of these complex statistical concepts of correlation and causation. And so, XKCD, of course, inspiration to all of us. But it's not limited to XKCD. There are other areas, I think, in journalism that are doing an excellent job in understanding the real science behind these things. Here's an article, for example, from The Onion. Again, gets the science right on. If that's your only standard, then this is excellent. Now, in my own field, I see a lot of science communication. Some of it's kind of depressing. Like here, this is from The New Yorker. Roz Chast, famous cartoonist, right? She talks about the Large Hadron Collider. I'm so excited, my research is in popular culture. Well, New Yorker, at least. But look at the last panel. What would happen if you put a cat inside it? Or if I concentrate ultra hard, will I ever be able to understand it? No. Oh, that was like a dagger in my heart when I saw that. Like, what? Come on. We can understand this stuff. So then I said, well, let's look at scientists. Maybe scientists are doing a better job at communicating the science because they understand the stuff, right? They're the ones in the lab, they got the results. They're not going to make mistakes. And so there's a lot of really fun examples of science communication by the people working on it. So here's, for example, one of my favorites. This is the Large Hadron Collider.
Oh yeah. I'm about to drop some particle physics into club. to apply. You know what I'm saying. Check it.
27.
So this is excellent, right? It's funny, it's informative, it's accurate. It got 8 million views. A lot of people learned some fun stuff about particle physics. Maybe these folks have like really figured out some recipe. Maybe they understood some way to penetrate to the public, right? So they followed it up with black hole rap, 75,000 views. And this is the challenge of going viral. Like nobody really understands why something will hit and something else will miss. It's also the danger of like judging the quality of your outreach by the size of the audience. I mean, for example, on YouTube, you can also find this video. It's delightful, I'll admit. I don't quite know why, but I do watch it and enjoy it. Then, of course, there are famous science communicators like Neil deGrasse Tyson, right? He's sort of on the edge of also doing culture war stuff. On another extreme, there's Sabina. Right? Sabina, who's out there telling people that the Large Hadron Collider is an experiment done in bad faith by scientists who are just part of some massive grift to suck money out of the government. And of course, there are excellent people. You know, Carl Sagan, still great. Younger folks like Katie Mack, doing great stuff. My personal journey in science communication began when I saw this cartoon. This is a technical comic book about the invention of the Chrome browser. Now, I'm a computer science kind of guy, but even I'm like not very excited about how you write a browser. But I read this cartoon, it's by Scott McCloud, a famous cartoonist, and it just describes how they did it and the challenges they faced. And the whole thing was very compelling and very accessible, and as far as I'm aware, very accurate. And I started thinking, you know, if you can make writing a browser exciting, maybe it's possible to use cartoons in this format to communicate our science as well, which I think is a little more compelling than just writing a browser plays. So I reached out to Jorge Chan. He's the author of PhD Comics. I'm sure all of you are aware. He's seen his cartoons around already, and they're on walls everywhere around the world. I didn't know him at all. I just emailed him because I was talking to my wife, and I said, I need somebody who has some artistic talent who can help me put this together. And she was a fan, and she said, why don't you just email him? And I thought, you can't just email him. He's like a celebrity. Like, next I'll email Brad Pitt and like say, hey, let's do a movie together. Anyway, I'm still waiting for a reply from Brad. But Jorge did write back to me. And he came down to Irvine, and I told him all about the Higgs boson. And he put together this really fun cartoon about Higgs boson and made our conversation entered down into a video. And this was a lot of fun, a fun project we worked on together. And then when the Higgs boson was actually discovered, it went viral and went all over the place and was picked up on lots of outlets, which was a lot of fun. And maybe my most proud moment as a particle physicist is when the Nobel Prize was announced for the Higgs boson. I was not named as one of the winners, of course. However, in the further reading section of the Nobel Prize citation, they linked to our video. So I didn't win a Nobel Prize, but I've been cited by the Nobel Committee, which is like a thin echo of a Nobel Prize. And then I saw this book by the author of XKCD, who's the guy who did that great cartoon about causation versus correlation. And this is a book about silly scenarios and science questions he was asked and clear explanations. And it's a mixture of science writing and science cartooning. So I mean, that's interesting. And the agent for Raymond Monroe approached me and Jorge because we were doing these science cartoons and said, hey, do you guys have an idea for a book? I could probably sell it, like I sold this one. So I thought, well, you know, do I have an idea for a book? What would I like to write a book about particle physics? Should it be about everything we've discovered about the universe and all the amazing things we've revealed? And I looked around and there's lots of books like that. Lots of people have written about here's all the particles and here's how they work and all the incredible discoveries. But it felt to me like not enough people had written books about the future of particle physics, things we don't yet know. And to me, particle physics is about the things we don't understand. It's about the exploration. When I was a kid and I was growing up, I didn't initially want to be a physicist. I wanted to be an explorer. I thought it was really cool to get to like land on some new island and be the first person to walk on that beach, the first person to eat that fruit, or see the Grand Canyon or something. But as a kid, when you grow up, you start to discover like, well, there aren't any more islands, right? Thanks to Google Maps, we know where our land is, and we've tasted most of the fruits. So what's left to discover? It's really incredible what we've accomplished as humans. I mean, you could get into an airplane and go across the country and give a talk. You can have all of human knowledge downloaded into your phone, or even have technological achievements in fast foods. I mean, it's really incredible what humans have accomplished. And so I wanted this book to be about how this idea that everything is already discovered is exactly the wrong one. And in fact, there's a huge amount left to discover. That most of the interesting questions in the universe have not yet been answered. So I wrote this book in 2017 called We Have No Idea. And it's about all these big questions. What is the universe made out of? What we haven't yet figured out. And it includes lots of fun cartoons, about ancient particle physicists going all the way back to caveman days. It includes, some charts with useful information, and then occasionally a little joke thrown in. And the idea is to engage the reader, get them interested in the big questions that we're asking, but not to write a stuffy book filled with equations, or even a book filled with fancy prose, but the cartoons are lighthearted to put the reader at ease, feel like, hey, these guys can make silly dad jokes, and probably I can understand what they're saying, right? And so we have lots of fun diagrams in here about particles interacting, jokes about antimatter, antiprotons, anti-books. We have lots of ideas. And the book was something of a hit, which is fun. It's translated into 27 languages at last count. And I wrote it in English, and I wrote lots of silly jokes in there. And I was sometimes emailed by the translators. The guy who translated it into Taiwanese was like, I don't really understand this joke. How do I translate this in Taiwanese? And I was like, I have no idea, man, seriously. Like, I didn't remember what that joke means. So that was a lot of fun. And then, the flip side, when you put something out into the public sphere, you get feedback. You hear from people what their experience is like to you. So, despite all of everybody's advice, I went and I read the comments. So some of them are wonderful. Like this guy who read the book and he laughed, he learned, and he probably didn't cry, but he had a great time, right? And this is exactly what I was going for. He enjoyed it, it tickled something deep inside him, he was curious about the universe, and he had a good time. Then there's other responses. This guy was upset that a book about all the unsolved mysteries in the universe didn't include his personal theory that explained all these things. So how could I not have cited it, right? Or this guy who was into the science, but like, please talk about the shows. I'm sorry, I'm just not capable of that. Pick another book. But this guy, our first 1-star review, let me tell you, as an author, it really hurts to get a 1-star review. Not just because it feels personal, but also because it hurts you in the rankings. We got a 1-star review because this book was delivered in the rain. What am I supposed to do about that? We had a lot of fun with this book, though. We went around giving talks at lots of different places, lots of different universities in the UK, the US, all over the place. About the book to public audiences. And every place I went, I also stopped and I talked to my colleagues in particle physics at the local university. And the question I most often was asked when I visited was, hey, cool, love your book. By the way, are you still doing any research? And so, I have some of my colleagues here in the audience. I just want to reassure y'all, yes, I'm still doing research. These are the papers I was an author of during my book tour around the world, so still prolific in publication. And at one of these events, there's somebody in the audience who saw our conversations on stage and the fun we were having together and said, hey, you guys would be doing a podcast. And this was actually about a year before everybody started a podcast. So it was a good time to get going. And so we launched a podcast called Daniel and Jorge Explain the Universe, and it was me and Jorge talking about physics. I would explain stuff, he would make jokes, we would have conversations back and forth. That was a lot of fun. Podcast ran for about 6 years. We did 2 episodes a week for 6 years, about 600 episodes, which means that now when they train AIs to generate podcasts, some non-zero fraction of that is trained on my podcast. I have a new podcast with my friend Kelly Wiener-Smith. She actually lives a couple hours from here. She's married to Zach Wiener-Smith of SNBC Comics. And together they wrote this excellent book called The City on Mars, about how we're totally unprepared to colonize Mars. It's a great book, and we have a lot of fun on the podcast. Some of you might be thinking, wow, a podcast twice a week, every week, that's a lot. How's that possible? You know, some podcasts, like This American Life, every single episode is like months of work, scripting, journalism, or whatever. Our podcast is not like that at all. It's a lightly edited conversation between two friends talking about science. And it's like you're hanging out at a bar with a couple of folks talking about science. And I rely very heavily on my colleagues in Irvine who know a lot more about than I do about some of these topics. So if I'm curious about galaxy formation, I can go down the hall and talk to James Bullock. If I want to know more about the early universe, I can talk to Manoj or Kev, or folks like this. So it was a wonderful crew there, and it's given me actually an opportunity to extend my knowledge of physics into other areas that I didn't have a chance to develop earlier in my career. We also talk to science fiction authors on the podcast about the science of their universes, which has been a lot of fun for me, just like fanboy, get to meet some of my favorite writers. You know, so I got to talk to Adrian Tchaikovsky and Alistair Reynolds. Alistair Reynolds used to be a physicist before he left the field and became a full-time writer. I got to talk to the screenwriters for All Mankind. Lots of fun. And on the podcast, we also tell people that we're interested in talking about physics, but also answering questions. As I was saying earlier, it's important for us to be accessible to the public. And so I give them my email address and I say, write to me, I'll answer every email. And so I get a significant amount of email from listeners. It's like a random day, you know, questions and questions and questions. People who have thought about something, had a question, or heard me say something on the podcast they didn't understand, or read an article on some nonsense clickbait science journalism site and send me questions. And I answer all of them. I paused though before I answered this kid's question. I thought, you know, I didn't promise to answer every question, but actually, we just got to this kid's mom before answering this question. Because I'm not in the business of like creating next generation supervillains. The podcast has been a lot of fun. It's been pretty well received. Here in the US, it's typically ranked in the top few of the natural sciences podcast, though it falls behind the COVID misinformation conspiracy podcast by Brett Finstein, and the #1 natural science podcast in the United States, the Sasquatch Chronicles. I don't know why that counts as natural science, or why that's more popular. In the UK, actually, they're doing something right, because we're ranked ahead of both of these podcasts. The podcast itself has also generated a lot of really interesting feedback. There are a lot of folks out there who've always been interested in science, but didn't have a chance to go into science themselves. And for them, an accessible digestion of the science scratches that itch a little bit, gives them access to this field without having to go back to university and actually study all of this. And here's a woman, she's 60 years old. She was inspired by the podcast to go back to university and get her degree in astronomy. And honestly, I was really touched when I saw that. But wow, I've influenced somebody's life in a positive way. You know, then here's an email from somebody whose boyfriend really liked the podcast, though she doesn't like it very much. And he's always putting it on, which is her. Here's somebody who listens to the podcast mostly because it puts them to sleep. Say, hey, as long as you're downloading it, you know, I'm good with that. Here's somebody whose podcast used the podcast as emotional support to get through the pandemic. You know? Here's somebody who used the podcast to drive his wife crazy on their long drives. And I didn't know what to say to this question. Thanks for sharing. Somebody who listens to the podcast while cooking and more than once has burned dinner because we got into something interesting on the podcast, which is great. So it's always fun to hear from the public. We got a lot of similar questions very often, so we decided to write another book. This one's called Frequently Asked Questions About the Universe. Basically, all the most common questions we got about the universe and about planets. This one also translated into several languages. And my latest project is a book coming out this fall, and it's called Do Aliens Speak Physics? And it's about the day that aliens arrive. And a lot of physicists imagine that when aliens come, we can talk to them about physics, because physics is the most fundamental language, right? It's the most fundamental science. Surely, I've had string theorists tell me, they will be doing string theory. Surely, I've had quantum field theorists tell me, they will write things down in terms of Lagrangians. And I feel like there's a lot of implicit assumptions in those claims. And so the book dives into these questions. How likely are we to actually be able to talk about physics with aliens? And how much is our physics a human project? So there's a little bit of philosophy there. So that's coming out this fall with a friend of mine, Andy Warner. He's a cartoonist in Irvine. And he got to draw lots of silly aliens. A few years ago, I had another fun experience. PBS put out a call for people who wanted to make a new television show. And they were specifically interested in broadening their community. They felt like they'd gotten shows from the Jim Henson Company and Fred Rogers, and over again, they wanted to have new creators. So we put out a broad call. And so Jorge and I put together a pitch for a show. We called it Eleanor Wonders Why. Eleanor was the name of Jorge's daughter. And I read a lot of articles about how children learn science. It's supposed to be for preschool science. And I thought, well, how do 4-year-olds learn science? What works in that scenario? And so I read a lot of papers, and there was very little on how 4-year-olds learn science, because science is often not taught to 4-year-olds. Because preschool teachers, on the whole, are afraid to bring up the topic of science with 4-year-olds, is because they're concerned the 4-year-olds are going to ask them a question they don't have the answer to. So the concept for our show was, let's have a bunch of kids who are curious, ask questions about the world. They go to their parents and ask the question. The parents don't know the answers. And then together they have to find the answers themselves. So the show is about learning the process. Learning science is a process. Not a list of facts, but like, hey, how do you answer questions that you have about the universe? And I was hoping that also parents who are listening to the show as they cook dinner and their kid watching it in the living room would hear the adults on the show not having the answers and think, oh, it's okay to not have the answers. It's okay when your kid asks you a science question, just get in there with them and figure it out. So that was our secondary idea. And you know how grant proposals work. You pour your passion into it, you send it off, and you forget about it. Because 1 in 100 of these things actually hit. So PBS got back to us and they were like, cool, wow, we like your idea, make us an episode. And I was like, what? It was just an idea. So I literally Googled how to make a TV show, because I didn't know anything about it, neither did Jorge. Mechanics of like how do you actually produce television. But we figured it out. Google is amazing, and we got to visit like the Jim Henson Company. We got to see the actual dark crystal Muppets in real life. It was super cool. Visit a bunch of other studios, figured out how to use special software to write for television, put scripts together. So the first season of the show aired on PBS in 2020, and it was a success. So a lot of kids watched it, a lot of kids liked it. Like, millions of folks have watched these episodes. One of the top 5 PBS kids shows, and a lot of parents reached out to us and said they really liked it. They said they liked that Eleanor, the main character, is smart and is always asking questions, just like they are. So that was really heartwarming. And it's on TV in almost 80 countries around the world. We started production on the second season a few years ago. We're just wrapping that up in a few months. So that's been a whole really fun science project for me. So that's my personal journey in science communication. Now I want to switch gears a little bit and talk about a case study of science miscommunication, what I think is one of the biggest fumbled balls in all of science communication that I think we can still remedy, but it's going to take some work. And it's about science misconceptions. It's about cases where scientists have an idea about how the universe works, and the public has a completely separate idea. And despite our best efforts to communicate what's going on, this misconception about the scientific ideas persists. And the number one, I think, number one case study here has got to be the Big Bang. Because the Big Bang means something very different when you talk to Joe on the street, even science-interested Joe on the street, and when you talk to scientists. Most people out there, when you say to them the Big Bang, they imagine a tiny dot of matter in infinite empty space, which then explodes out to create the universe. And they think of it as the beginning of the universe. So, popular science conception of the Big Bang is, number one, it's the origin of the universe. Number two, it's a single dot of matter exploding out into empty space. If you talk to any scientist who knows the Big Bang or works on it, you know that the Big Bang is not about the origin of the universe. It's about backtracking our understanding of quantum field theory to the earliest understood moment, some moment of high density, before which there is speculative science, inflation, et cetera, but the hot Big Bang itself is not an explanation of the origin of the universe, it's a description of the expansion from that hot, dense moment. And it's not a single dot in empty space, right? It's something that happened everywhere. We all know that. We're on the science side of this. But most folks out there think it's the opposite. And as a result, they have questions that don't have reasonable answers. Questions like, this guy asked this question on Twitter very recently, this is March. Neutrinos travel at very near the speed of light. They observed neutrinos originate with a Big Bang. How did we get here ahead of them? Right? And it's a very reasonable question. This is what people are doing. They're hearing what you're saying, they have a model in their head, and they're asking reasonable questions about it, which is what we want people to do, right? That's doing science, that's being a physicist. But they're starting from the wrong place, because they're imagining the universe is this tiny dot, which then explodes out. They think that it happened somewhere. They look back and ask, where was it? Why can't we reconstruct it? All very reasonable questions if you start from the wrong idea. The Big Bang has lots of problems in science communication. We'll get to the actual science of it. But even the name Big Bang has been miscommunicated. The story of the naming of the Big Bang in the public eye, in the public consciousness, is actually totally false. So here's a quote from some of George Gamow's collaborators, Alfred and Herman. They claim that near the end of '49, Gamow was engaged in debate with Fred Hoyle of steady-state theory, and that during this debate, Hoyle said the Big Bang, as a sort of dismissive comment about this theory. And that's the name of it. It originated as sort of some science slur during this debate, right? And it's a great story. Unfortunately, none of that story is true. Hoyle did not engage in debate with Gamow. As far as I can tell, he never even mentioned Gamow in any of his writing or any of his speeches. He was on the BBC as a solo interview, and they turned that into a book the next year. Gamow not involved at all, so there was no debate, number one. He did, this is the first time he ever used the phrase Big Bang. He described this idea, this Big Bang idea seems to be unsatisfactory. But science historian Nels Krag dug into this deeply, and he concluded that the evidence that this was seen as some sort of derogatory comment is completely inconclusive. There's really no evidence to support it. The reactions of folks afterwards make it seem like it was just a description, just a word he used to describe the idea. It's not derogatory at all. So even the name the Big Bang has been miscommunicated. There was no such debate, it never happened, despite Alfred and Herman's claim that it did, and it was not used as a science slur. So I was curious, where did this all went wrong? Where did the public get the idea that the Big Bang was this tiny dot of matter in empty space? So I went back and I found the earliest article I could about the Big Bang, and this is 1965 by Walter Sullivan. Walter Sullivan, famous science journalist. There's now the Walter Sullivan Prize for Science Journalism, right? That's how the height to which he ascended. Read this article about the then recent discovery of the cosmic microwave background, and here's a few quotes from it. Right? He talks about it as an explosion that gave birth to the universe, that originated in a single point when the universe was born and expanded into infinite space. So this article, I believe, is the origin of all of these misconceptions. I think a lot of science journalism happens by reading other science journalism. And so once you have one misidea, especially if it's very compelling, it's like a harpoon into the minds of people and other science journalists, it propagates itself. And this is not an easy thing to cover, right? I spoke to Virginia Trimble, who's at UC Irvine, and she actually knew Walter Sullivan quite well. And I asked her about this article because Sullivan's not around anymore. I can't ask him, like, why did you write these words? And she said, you could rely on Walter to describe the experiments, but on the theory stuff, he was a little bit less reliable. But it's not an easy thing to figure out because the ideas at the time were complicated. Like, go back to Lemaitre's article. This is an incredible paper, Nature, in 1931. 4-paragraph paper in Nature, where he talks about the origin of the universe as in a unique atom, or sometimes it's translated as primeval atom. So you have to wonder, like, Walter Sullivan's trying to understand these things early on. It makes sense that you might be confused. Why does Lemaitre call it a primeval atom instead of describing the whole universe? It's because he thought in the moment that the universe was finite. He was actually describing a universe that's still filled with matter, not a tiny dot in empty space, but a universe filled with matter. So consistent with modern conceptions of the Big Bang, though easily misunderstood. It's hard to get your mind around a finite universe filled with matter. I asked my friend Andy to draw an image of a universe, a finite size, filled with matter, and this is what he sent me. Himself puzzling. But once this idea was out there in '65, you see it propagated through popular media everywhere. Here's, for example, like the Kankakee Daily Journal talks about the Big Bang, describes it as a fireball that exploded 16 billion years ago to create the universe. So all those wrong ideas are important. Now, only a couple of years later, you see scientists trying to push back on this. So here's Peebles and Wilkinson in Scientific American in 1967. They already recognize that we fumble the ball, that people misunderstand the Big Bang. And they say, yeah, this could be kind of misleading, this idea. And they explain it's not localized in one corner of the universe. But it's too late. And also, Scientific American, the previous month, ran this depiction of the Big Bang, which you could reasonably misunderstand as saying that the universe came from the same thing. 10 years later, here's Weinberg pushing back against this idea again, right? It was everywhere, it was filling all space. He even goes into his characteristic detail about like what we mean by all space. And even if it's finite, we still mean all space. This is excellent, but not widely enough read. And then, in the New York Times, the next month, is this depiction of the Big Bang, which is like Jack Kirby-esque, exploding planets. And again, this hurts us when people don't understand what we're actually talking about scientifically. They have a misunderstanding because then we lose credibility. Here's a conversation on Twitter about two folks who don't accept that something smaller than a piece of sand blew up and became everything. Right? Again, they're starting from the wrong idea, thinking it's ridiculous, and then dismissing science, and concluding everything you've been taught about how the world works is a lie. This is the problem with science miscommunication. When you get it wrong, people think it's bullshit, and then they think you're lying. All right, so let me talk a little bit more about whether or not you should be doing science communication. Let me do that by telling you about what it's been like for me as a scientist, trying to navigate both of these avenues. A lot of people, again, are asking me, should you still be doing research? Before I answer it myself, I asked two other science communicators their thoughts on whether young people should be doing science communication. So Sean Carroll, of course, very well known in popular media, also academically, though he had his career somewhat derailed by writing a textbook early on, which was created in Chicago, not to give him tenure. So he ended up at Caltech, so not so bad. But he says doing outreachy things will lower the percentage of people someday become tenured. Steve Strogat's a math professor who also writes broadly for the public. Says if you're going to do it in the academic setting, get tenure first, do your research, and then go on.
Doing
If you're going to do it in
So again, let me just tell you, my research program is still active. I'm still publishing a bunch of papers. Just after my big tour for my book, where I got a lot of publicity, I went up for a promotion at UC Irvine from associate professor to full professor, and there was a vote in the department whether or not to approve my promotion. And I set the record at the time for the most negative votes. So this still passed. I got promoted. But there were some folks in the department, which in general, the sunshine is out in Southern California makes people very congenial. In general, they're very supportive, but there are some folks out there who just, they didn't get it. They didn't understand how I could be writing books and also doing science. So they voted no. And very unusually, this prompted a letter from the very highest level of review, kind of rebuking those folks and saying, quote, that this kind of creative thinking may well do more to advance physics than more traditional work. And the response actually gave me a little bit of accelerated promotion. So getting these 7 negative votes actually did end up helping me personally. All right, so why should we do science communication? So I think it's important. We owe something to the folks who are paying for our science to explain to them what we've learned. It's important to do it accurately. And when we do it right, it can really make a difference. Here's an email I got from a listener to the podcast in 2019. She says she's 12 years old, she's been listening for over a year, she loves it, she's really interested in maybe doing science later on in her life. I heard from her again 5 years later, this is now just last year, and she said, you probably don't remember me, of course I remember her, and she told me she was coming to UC Irvine to study physics, partially because she wanted to meet me. And so last year I actually got to meet her in person. She came to UCI, and she's now a freshman physics major. And so you can really have an impact on individuals, change the course of their life, improve for the better. So those of you who are interested in science communication and passionate about it, and senior enough to weather the slings and arrows on your career, I encourage you all to give it a shot. Thanks very much.
Are there questions for Daniel? So we have Tom Cohen here.
So I very much enjoyed your discussion of the Big Bang. But I'm reminded of a comment of Niels Bohr, who said that accuracy and clarity are complementary variables. And part of the problem, of course, is, while the Big Bang can be described, as a raisin loaf expanding, et cetera, it's still an idea which is somewhat subtle, and it's very easy to give some sense of an expanding universe by thinking of it as a grain of sand exploding, and that is clear without being accurate. As you try to get accuracy, though, you're going to lose people. So how do you sort of navigate that issue?
Yeah, it's a challenge. You're totally right, and it's easy when you're communicating science to fall back on these analogies, but you have to be really careful. Another example is like explaining black holes with a whole rubber sheet with a bowling ball in it. Right? Lead people down crazy alleyways because they don't understand which aspects of your analogy you mean literally and which aspects you're like, oh yeah, but forget about that part. And so you have to be really careful. I think it is possible. Disagree with the esteemed Niels Bohr. I think it's possible to be accurate and clear. It's just a lot harder. I think it's worthwhile.
Are there other questions? Can you pass that? See on video conference.
Thank you for the talk, Daniel. I very much enjoyed it. I think one of the places where an ordinary faculty member like myself might encounter science communication issues is you've got a new result, and there's the question about whether there should be some press release or something. And I wonder if that, the motivation for that is very clear, why the university might want to put out a press release. And certainly, as you pointed out, we're publicly funded. Certainly we should be explaining what we're doing to the public. But I wonder if in that kind of culture, that kind of incentive, if we're not compelled or motivated to exaggerate the importance of any particular result. The vast majority of science is very incremental. And in a press release, you're not explaining that. You're trying to explain what's new, what the new idea is. But I wonder if this culture of trying to get our science out there to the public doesn't incentivize us to be a little bit less than fully transparent about the incremental nature of most new results.
I completely agree with what you said. And that's why I think you see so much science journalism, which is overblown. And most science journalism out there, I really believe. When I read about my own field, I'm like, yeah, that's not
Exactly. When I read the results from my own field, I got my own perspective, and it makes me take with a grain of salt results from other fields.
exactly, which undermines their credibility. They're like, I can't believe this. And people write to me all the time, they're like, what science journalism can I believe? And there's very little out there. But I think you have to cultivate that credibility by being honest, by only writing about stuff that really is exciting, by framing it correctly, connecting it to those big questions. I think one outlet that gets it much more often correct is like Quantum Magazine. You know, they describe only big advances, and I think they do it quite well in a way I think is pretty credible. So I think we have to cultivate credibility by being honest about when something is exciting and when it's not. And I hope that eventually we can regain some trust in institutions and have a shared set of common facts because we develop that credibility. But I think it's a long process. It's hard. And I agree, a lot of our immediate incentives are weaknesses.
So along the same lines, about young people trying to get promoted by explaining their work, you have one of the things that young people want is to have their stuff in Nature. And Nature, and journals like that, science, want stuff to be flashy. And as my colleague Annie said, they're almost more often than not wrong because they want it to be flashy. But so what do we do about the fact that when our own journals, the ones that are often most respected, are the ones who push us to be more, as Carter says, on the edge, and how this has to be spectacularly new to get into the journals that people want us to publish in, to help young people get promoted?
Yeah. Well, academic publishing has, wow, so many problems that we should fix. But you're right, and I've had folks tell me that they wrote a long, detailed paper and it was rejected, so they cut it in half and sent it to Nature without all the explanations, and then it was accepted. That kind of story is one thing. I think partially that's our fault, because we are the audience for that. We hire people who have Nature papers, and everybody's going to want a Nature paper. So it's maybe on us to learn to evaluate people in other ways, deeper ways, that aren't so reliant on these metrics. So yeah, it's a systemic problem.
Yes. Thank you.
Thank you, appreciate it. Thanks, that was a great talk. So how would you recommend us as physicists and scientists going out into the wilds of the public, how we should communicate various scientific findings to those that didn't necessarily logic themselves into their own position and whose position may be wrapped up into their own identity or culture?
Yeah, I think everybody's going to follow their own passion. You got to do something that's authentic to you. You like giving talks to kindergartners, do it. If you have artistic skill, you think you have a way with words. I don't think there's one recipe for everybody. I think it depends on the individual. And I also think it's not crucial that everybody does science communication. Some people are not into it, and they shouldn't be doing it if they don't want to, because they're not going to do it well. It's just like not everybody wants to be department chair. That's cool. So you should be doing it if you're into it, and in a way that I think is personally meaningful to you. So that's sort of a non-answer. I apologize. It depends on, I think, too much on the person.
Well, my question was more with regards to, say, I'll be more particular. Say you're talking to someone who doesn't believe in global warming. That was my question, really. How do you communicate a scientific finding that the community believes in and knows as a fact to someone who has a certain viewpoint on an issue where that viewpoint is wrapped up in their own identity?
Yeah, it's challenging. It would be helpful, again, if we had shared facts and institutions we trusted that we could agree on. I think a lot of the degradation of credibility of science, I mean, obviously a lot of it's political, but a lot of it is due to our failure to clearly communicate. So I think we can do a better job.
Mm-hmm.
But I think that's a very difficult problem to solve. I'm grateful that Big Bang and stuff like that is less political than global warming. hope that the guy who I send instructions to doesn't end up actually destroying Mars.
Was that Elon Musk?
It's one of his kids. All right, thanks everyone.
All right, if there are no more questions, yeah, let's give